In this video, we'll present Autostrap software and its key features. Autostrap allows users to create a 3D model in Strap from a DXF format CAD drawing. Autostrap automatically identifies beams, columns, walls, and contour lines when importing a DXF file. It enables the user to modify these elements to define loads and create a 3D model in Strap. We'll demonstrate the working flow with the next example. First, let's take a look at the DXF files. The first DXF file name is st-6 to 0. The layer concrete walls is represented by green lines, and the layer concrete columns is represented by the gray lines. The second DXF is called st-124. In addition to the wall layer and the column layer, which is represented by yellow lines in this drawing, we can see another layer named slab edge, which is represented by gray lines. This layer is basically the slab contour. The third DXF drawing is called st-5 to 20. In addition to the walls, columns, and contours, there is another layer called concrete beams, which is represented by a cyan color. Wall openings and beams cross-sections are represented by text. The element, wall or a beam, and the text that is related to it must share the same layer in the drawing. Wall's opening text will allow Autostrap to extract the opening height value. Beam's cross-section text will allow Autostrap to extract the beam section height. Let's move on to Autostrap. When starting a new project, Autostrap will start by asking us to select the DXF file to import. Let's select st-6 to 0. The next window, DXF Properties, will allow us to assign the DXF drawing layers to elements in Autostrap. The Assign To list includes Do Not Load. Do Not Load means that Autostrap will not load the drawing layer. Next, we have beams, walls, columns, and contours, and Unassigned. Unassigned means that Autostrap will import the layer but won't assign any element to it. This option can be used for reference or to be assigned later on. For the current DXF drawing, we will assign only two layers. Layer number 5, concrete walls, will assign it to walls, and layer number 6, concrete columns, will be assigned to columns. Also in this window, we'll have to set the units of the DXF file we imported. In our case, centimeters. After clicking OK, we can see the program imported and converted the DXF drawing to Autostrap elements. Let's zoom in to check our wall openings. We can see that Autostrap imported the text that represents the opening as well. In order to import the next DXF, we'll go to DXF Files, then Add DXF. We'll select st-124. For this DXF, layer number 4, Slab Edge, will be assigned to contours in Autostrap. We can see the contour lines, the walls, and the columns. In the same manner we imported the second DXF, we'll now import the third one. Layer number 5 of this DXF concrete beams will be assigned to beams in Autostrap. The drop-down menu on the right of the screen will allow us to move between the 3DXF files we imported. Let's go back to ST-6 to 0. We can display the mesh that Autostrap created to check that everything is okay. Next, we would like to create levels for our future model in Strap and assign drawings to any level. Go to Levels and Add Level. Let's add 26 levels with a typical level height of 3.5 meters. We can see 26 rows in the left column, which represent the number of levels. At the top of the window, we can see base level. We need to define our base level height coordinate. For our example, we'll define base level at -15. We can see that the level of our floors was updated automatically. Now, let's assign a drawing to each level. Levels 1 to 6 are already assigned with ST0 to 6. We'll assign ST1 to 4 for levels 7, 8, 9, and 10. And for the rest of the levels, we'll assign ST5 to 20. We can also adjust a specific level height. Let's change level number 7 height to 6 meters. Now, we'll define an origin reference point to allow Autostrap to align our levels correctly. Clicking on Origin will open up the origin point definition window. In it, we can choose one of the items: a column corner, beam or a wall corner, a contour line end, or any line end. In our example, we'll choose this wall corner because it appears in all the drawings and it's aligned in all the levels. The green cross represents the origin reference point in each drawing. We'll do the same for the next two drawings. Now we can create a strap model. Go to Strap and create a model. Name our model Demo 1 and select a project folder. After creating the model, we'll move on to Strap. We can see the model Autostrap created and see all our floors aligned. Now let's go back to Autostrap to review some features. Clicking Parameters in the main menu will open the Parameters submenu. Mesh parameters allow the user to set the mesh density. The selecting option in mesh parameters refers to spaces. Autostrap identifies areas with contour, wall, or beam lines at its boundaries and divides the mesh into spaces. Each space is assigned with a number, and each space can have its own parameters assigned to it. We can see the boundaries of space 21. To the left, we can see a contour line and beam lines in all other directions. Space 18 was divided by wall lines boundaries. The options that are available in mesh parameters are the size of an element in a mesh in the X direction or the Y direction, the minimum element size, angled elements, or we can choose not to create a mesh in a specific space. Let's see an example on an individual space. We'll select Do not create a mesh. The next option in the submenu is Thickness. As a default, Autostrap will assign element thickness according to the default thickness parameter in the setup menu. In our example, 20 centimeters is the default value for thickness in the setup menu. The thickness option will allow us to revise the thickness of spaces. -1 in the slab thickness window will assign a hole to a selected space. Next is beam section. This option allows the user to revise beam sections. After selecting a beam, we can revise the section, change just the beam height, add a flange, or remove a flange. For this example, we'll change just the beam height to 75 centimeters. Next in the submenu is Wall Opening. This option allows the user to revise an existing opening or define new openings. Let's add an opening. W is the opening width, H is the opening height, DH and DV are the relative coordinates of the wall opening position. Display opening data will give us the data for the openings in our walls. We can also edit an existing opening or delete a predefined opening. The DXF file option was reviewed earlier on. We use it to import DXF files. It allows the user also to remove a DXF drawing. The reload option will allow us to reload the drawing after revising it. For example, let's change our third DXF in the CAD software. Let's add an opening in our slab. The layer will be contours. Save the drawing and go back to Autostrap. In DXF files, let's reload DXF3. We can see the new space Autostrap created. Now we can define an opening with thickness equals to -1 in slab thickness. We can see that the parameters we revised for the beam section remained unchanged, even though we reloaded the DXF file. Reload will keep revisions made within Autostrap. The levels option, as explained earlier on in this video, allow us to define a number of floors and assign a DXF drawing to each floor. DXF lines in the main menu will allow us to add or delete elements that were defined by Autostrap. Let's see an example for our first DXF. We'll change a wall segment to a beam. Select Add Beam. Select 2 lines of the wall segment. The program gives a message that these lines are already assigned to an element. Select these lines and erase existing elements will replace the wall segment with a beam. We can clearly see that we revised the wall segment to a beam. Loads in the main menu will allow us to define loads. Slab load allow us to define an area load in selected spaces. There is no need to define the load with a minus sign. The program default is that the load direction is downward. We can apply the load to elements or distribute the loads to beams. We'll see an example further along in this video. We have the option to include self-weight in the dead load in Autostrap or to add the self-weight in Strap later on. We can display the loads we defined in Display Slab Loads. We can also define beam loads. Let's see an example for our third drawing. Select a uniform load, select a beam, and define a dead load of 2 tons per meter length and live load of 1 ton per meter length. We can also define a concentrated load for beams. Select concentrated, select a beam, and we can see a cyan arrow and distance from a reference point on the bottom left of the screen. We can also change the reference point. In our case, we'll select a position of 6 meters from our reference point and define a dead load of 8 tons and a live load of 2 tons. The next option in the main menu is Strap. This option allowing us to set parameters of our model. Let's see the Defaults tab. In Defaults, we can define the default connection points between submodels and the main model. The DXF that we imported will be a submodel in the strap model. Connection points are the points connecting the submodel, usually the slab and the beams, and the main model, usually the columns and the walls. We are able to define connection point types for columns and walls separately. We can also define the restraint type at base level. Type of column offset. To position columns correctly, sometimes the program will use offsets. We can define if to include the moment that is generated from offset eccentricity or to ignore it. We can also create rigid links in a plane. This option will create rigid links in a slab plane, usually x1 and x2 if x3 is defined as the height axis. This option usually is used for dynamic analysis, where the slab acts as a diaphragm with infinite stiffness in its plane. Nodes in column area connect to column connection nodes with rigid links. In cases where we find slab nodes in column section area, we can link them to the connection points of the column. We can see column 13. Inside the column section, we can see many nodes: 5721, 5722, 5723, etc. If we connect all these nodes with rigid links, the column will provide support for the slab with its entire section, not just the connection point node. The next option is extend beams into columns. Remember the default value of 40 centimeters, and let's see an example. We can see an offset in column number 5. The program inserted the beam 40 centimeters into the column section perimeter and created an offset for the gap that is left. If we change the value to 20 centimeters, we can see that the offset got bigger. This option is usually used to set the support distance for a beam which is supported by a column with a large section measurements. The next option is nodes along a wall center line. When working with submodels and walls in the main model in Strap, the program will assign connection points in the wall section perimeter if the distance between the nodes is greater than 40 centimeters. If the distance is less than 40 centimeters, the program will create a rigid link to the closest connection points. We can see an example in the Strap model. We see the supports in the submodel that represent connection points, but we can see two nodes without a support, because the distance between them and the connection points is less than 40 centimeters. We can see a distance of 37.5 centimeters. And we can see that the program assigned rigid links in all directions. We can define the maximum value in Strap Model Defaults window. So far, we defined default parameters. Column parameters will allow the user to revise the same parameters for selected columns. We can see we can define the connection point type of column offset, and beam ending at columns. After clicking OK, the program allows us to select the columns we want to assign these parameters to. The final stage in Autostrap is Create a Model. With this option, we will create a model in Strap according to our definitions in Autostrap. We can name our model. We have to select a project folder. Overwrite an existing model with the same name. Create a plain model. We'll create a model that includes only the current drawing. Let's create a plain model of the current drawing. The columns and the walls will act as supports in this kind of model. Let's call it Demo number 2. We can see the supports at the location of the columns and walls. Let's go back to Autostrap and present the next option in the main menu, Beam D. Let's clean our display to make it more convenient for work. Beam D allows the user to transfer the beams in Autostrap to Beam D software. Let's define slab load to all spaces. We'll define 1.2 tons per square meter for dead load, 0.25 tons per square meters for live load. We'll apply the load as beam loads. When we apply the load as beam loads, we have two options for load distribution. We can either choose bidirectional or unidirectional. In our case, we'll choose bidirectional. We can see for every space 2 arrows in 2 directions, which represent the load distribution. We can display load distribution to beams and see the distribution of the area loads to the beams. The options available in the Beam D submenu in Autostrap include column numbers, which will allow the user to edit the column numbers, and beam numbers to edit beam numbers. Another option is supports. This option allows us to review and revise the beam supports. We can see the support numbers on top and the span length and support width at the bottom. We can revise the start and supports. We can change the support width, delete a support, or restore defaults. Edit beams will allow the user to modify Autostrap's definition. For example, to modify continuous beam span to simply supported beams. Design will allow us to review the design of a selected beam in BeamD. BeamD will allow us to create a BeamD project for selected beams. We'll select a project folder and a project name. The design option will take us straight to BeamD, where we can see the beam section, and the loads. Plus, we can let BeamD design our beam. Let's go to the project folder of BeamD. In the beams list, we can see that all the beams were transferred to BeamD. Now we would like to add a few comments. In every case where there is a change in the supporting elements in a certain level, we will have to import the DXF again to allow Strap to create a different submodel with different connection points. Let's see an example. On level -6 to 0 and 1 to 4, we can see that the supporting elements are different. In levels, we can identify level 6 as the level where the change is occurring. We will have to import the DXF ST -6 to 0 again and assign it to the 6th level to create a different submodel. The same applies for level 10. In DXF files, we'll add ST -6 to 0 again. Define the origin point again, and also import ST124 and define its origin point. In DXF files, we can edit the name of the DXF we just imported. Let's add top for the two DXFs we just imported. In levels, we'll assign ST -6 to 0 top to level number 6 and ST124 top to level number 10. This is how we allow Strap to create different submodels with different connection points for these levels. In Autostrap, we have a setup window. We can access it through File, Setup. In the General tab, we can set the DXF default units and the default materials. Automatically load the last used project. If checked, Every time the user opens Autostrap, the last used project will be open with it. Default beam height will use Autostrap to assign a default height to beams where there is no text available. Default slab thickness sets the initial slab thickness measurement when importing a DXF. Max min beam width are the min max width measurement for which Autostrap will identify beams. The same applies for walls width min max. Default element size refers to the mesh element default size. Minimum element size refers to the smallest size of mesh element that Autostrap will create. The next tab, Drawing, includes parameters in the drawing. For example, the origin mark size. In the tab Colors, we can edit the colors that displayed on the screen with Autostrap. The final tab, Pen Width, allows the user to control the width of the lines or the width of the text. One last important note. Autostrap allows the user to create geometry and load definition for strap and beam D. With Autostrap, the user can define complex models in a relative short time. After the model is created, we can review it and edit it in Strap. Autostrap doesn't replace the experience and knowledge of analyzing structures and defining a model for calculations. Thank you very much for watching.